If you are building modern distributed systems, you need a continuous, high-speed flow of data. Traditional request and wait architectures simply cannot process that volume. gRPC solves this problem. By relying on HTTP2 and using protocol buffers, it compresses your data into lightning-fast binary streams. A standard REST payload is human-readable text, while gRPC is an unreadable binary sequence, causing generic REST tools to fail. Additionally, REST operates on a single back-and-forth ping, whereas gRPC establishes a continuous bidirectional loop. Your old REST tools cannot adapt. Migrating to a gRPC architecture requires adopting a specialized testing toolchain just to read your own data. For years, the undisputed industry-standard GUI for local gRPC testing and debugging was BloomRPC. But as the ecosystem advanced, the software decayed. It was unable to handle modern .NET Core setups, leaving developers constantly fighting SSL and TLS connection failures. Now, the project is dead. The BloomRPC GitHub repository is officially archived. There are no future security patches, and no bug fixes are coming. The collapse of the default tool leaves behind a fragmented market. The software is split between simple, local desktop applications and massive, cloud-based enterprise platforms. Choosing a replacement determines how much time you'll spend configuring environments versus actually testing code. You have to match the tool to the technical scope of the task. This chart shows our evaluation framework: setup effort versus testing scale. Let's start with the solo debugger, a developer needing to quickly ping endpoints without cloud overhead. Here, you choose local-first desktop applications like Kreya or gRPCMD GUI, which sit in the low-effort, low-scale quadrant. These clients deliver immediate visual debugging and keep your payloads local. They also feature server reflection, automatically fetching available methods directly from your code. Because they lack built-in team collaboration, the trade-off is isolation. Now, if you skip the GUI entirely, the gZ command line interface sits right next to them in the low-effort quadrant, providing instant terminal benchmarking. However, gZ requires terminal fluency. You sacrifice visual interfaces and advanced exportable reporting. These solo tools maximize individual engineering velocity, but they break down when multiple engineers need to coordinate on the same API design. This chart also helps frame the enterprise collaborator, teams managing complex catalogs of both legacy REST and new gRPC endpoints. Migrating an entire engineering team to all-in-one platforms like Insomnia or Postman pushes you into the high-effort quadrant. In exchange, you gain native Git sync, shared team workspaces, and centralized API governance systems. Architecturally, these platforms carry a much heavier resource footprint on your local machine and introduce the risk of vendor lock-in. Financially, they require premium subscription costs per user to unlock essential identity and security features. These platforms effectively organize distributed engineering teams, but they introduce unnecessary friction if you are a solo developer just testing a single microservice. Finally, we evaluate the load tester, engineers tasked with ensuring the architecture survives spikes in traffic. For example, if you need to stream real-time industrial drilling data to 10,000 engineers simultaneously without lagging, functional debugging isn't enough. This chart puts cloud-based platforms like PFLB in the high-effort, high-scale quadrant. PFLB's operational advantage is raw computing power. It simulates millions of concurrent users without requiring you to provision your own server infrastructure. The trade-off is price. You pay custom enterprise rates for managed infrastructure. But if you handle the infrastructure yourself, scripting-heavy tools like K6 occupy the low-setup, high-scale quadrant. K6 lets you write highly customizable, version-controllable test scenarios in standard JavaScript. The trade-off here is the steep learning curve. It requires dedicated performance engineers to manually write and maintain all the testing code. Load-testing tools trade daily simplicity for the ability to predict and prevent production failures. The final choice of testing tool must be dictated by your actual operational scale. This flowchart maps the decision. You must determine your primary goal. Are you functionally debugging or architectural load testing? On the debugging path, solo developers should route to local GUIs like Kreya or gRPCMD GUI. Distributed teams should route to enterprise platforms like Insomnia. On the load testing path, engineering teams willing to script their tests route to tools like K6. Teams needing managed infrastructure route to cloud platforms like PFLB. Misaligning your tool choice with your actual scenario leads to paralyzed team collaboration or severely bloated local workflows. Do not hold on to deprecated tools like BloomRPC merely because the interface is familiar. That results in wasting hours fighting SSL connection errors instead of actually building features. If you are testing solo, download Kreya or gRPCMD-GUI today for immediate local debugging. If you need to coordinate multiple engineers, adopt Insomnia to align your team on a single source of truth. If you are preparing for high traffic, invest in PFLB or K6 to guarantee your servers won't melt under production loads. The gRPC ecosystem has evolved completely past single tool dominance. It now requires engineers to select software that matches the specific technical requirements and team size of the project. The final choice of testing tool must be dictated by your actual operational scale. Determine your primary goal, functional debugging or architectural load testing. For debugging, solo developers use local GUIs like Kreya or gRPCMD GUI, while distributed teams use Insomnia. For load testing, scripters use K6, while teams needing managed infrastructure use PFLB. Misaligning your tool choice with your actual scenario leads to paralyzed team collaboration or severely bloated local workflows. Don't hold on to deprecated tools like BloomRPC just for a familiar interface. You'll waste hours fighting SSL errors instead of building features. Testing solo? Use Kreya or gRPCMD GUI. Coordinating teams? Adopt Insomnia. High traffic? Use PFLB or K6. The gRPC ecosystem has evolved past single tool dominance. You must select software that exactly matches your project's technical requirements and team size.